Hello, good morning, first year MSc students. So, this is B. Verom Krishna, Assistant Professor, Department of Physics, AKNU, Rajahmundry. So, today, in previous class, we have discussed the tunnel diode and photodiode. So, now we are going to discuss about solar cell. Okay. So, the, the most common use of the renewable energy is solar energy. So, see, how is the solar energy used to generate this electricity? A photovoltaic or PV system is used to convert the solar or light energy into the electric energy. So, you know in your daily life you use solar cells in various applications, right? So how this energy produced when light hits the surface of this metal plate of the solar cell, okay, the electrons will eject from this conduction, means valence band of the some any type one electrons from the valence band of one semiconductor. It will go to the towards the p type of any semiconductor. Okay, there is a flow of electrons from n type to the p type. So there will be a generation of electric current. So photovoltaic or PV system is used to convert the solar or light energy into electrical energy. The basic components of the PV system is solar cell. The basic component of PV system is solar cell. Solar cell have able to produce 0.5 volts electricity. Each solar cell can produce 0.5 volts electricity. The solar panel or solar module is a combination of solar cells. So the red mark, there is a one cell. This cell is the solar cell. The combination of all the cells, which is called a solar module or solar panel. The solar panel voltage can be increased by increasing the number of solar cells. So we can increase the voltage of this solar panel by increasing the solar cells, by combining the solar cells. So if you want to produce that 15 volts, so each cell producing the 0.5 volts. So if you want to produce the 15 volts, then you have to arrange the 30 solar cells to produce the 15 volts. If you want to produce the 15 volts, so each cell can produce 0.5 volts. To get a 15 volts, you have to arrange the 30 solar cells. How does the solar cell work? The generation of electricity in the solar panel on exposure of solar light is known as photovoltaic effect. So what is photovoltaic effect? So here you can see the sunlight is falling on the solar panel. Okay, so when it is fall on this solar panel, there will be a generation of electricity. This effect is called a photovoltaic effect. Okay, photovoltaic effect means when any light that falls on the a solar panel, then there will be a, if there is a generation of electricity, then this effect is called a photovoltaic effect. Okay, this is the principle used to produce the electricity. Solar cells are made up of semiconductors, mainly silicon, comprised of 3 layers. Okay, so basically solar cells are made up of semiconductors, like silicon semiconductor comprised of the 3 layers. So top thin layer is the n-type material. N-type means n-type, in n-type semiconductor the majority carriers are electrons. Okay, magnetic carriers are holes. When comes to the p-type, it is a, the majority carriers are holes and magnetic carriers are electrons. So when we combine these two, the n-type and p-type semiconductors, there will be a formation of one p-n junction, that is called a depletion layer. Okay, the top layer is n-type layer, is completely thin, contains high concentration of electrons. Bottom layer is a p-type material, contains high concentration of holes. So when n-type and p-type join together forms a p-n junction. The electrons in the n-type electrons try to join with the holes in the p region. So when we join together of n-type and p-type material, what will happen means p-n junction will be formed. So then there will be then the electron will try to flow from the n region to the p-type region. Okay, so there will be so that there is a creating a negative charge layer near the p-type region. There will be a positive charge layer which is called a whole charge region near the n-type material. The region of these two layers is called depletion layer, that we call as a p-n junction layer. The sunlight penetrates the top thin layer easily to reach the depletion region. Due to the charge deficiency in the depletion region, it contains the neutral atoms. So what happens here is so here is the picture. So in the n region you have a high concentration of electrons, in the p region you have a high concentration of holes. So when electron so I'll try to explain in detail. Okay, so this is the n region, this is the n region, this is the p region. There is a in between n region p region the depletion region is formed. Okay, so there is a high concentration of electrons. Okay, there is a high concentration of electrons, but we have a, the positive charge indicates the holes. So remember, in n region magnetic charge carriers are holes, in p region the magnetic carriers are holes. Okay, okay, so when we join these together, there will be then the depletion layer formed. How? Because the electrons will flow from negative region to the positive region. Okay, then there will be a formation of negative charges at the near the region of p region. Then electrons means the positive charges will flow opposite to the flow of electrons. Then there will be formation of holes near the region of n type region. So there will be the electric field will generate in between the depletion region. So there will be generation of electricity. Okay, so So when sunlight when sunlight the falls on the depletion, the topmost layer of means n-type region, the electron will try to move towards the p-type region. Okay, so this electron will easily penetrate to the depletion region due to the charge deficiency in the depletion region. It can the depletion region contains only the neutral atoms. Why this depletion region have the neutral atom? Because this positive charge and negative charge will combine each other, so there will be formation of neutral atoms. So there will be in depletion region there is a more number of neutral atoms. Okay, what I'm trying to say is when sunlight falls on the surface of the n region, okay, this electron try to move towards the p-type region due to the existence of electrons. So when electron is try when when electron is trying to move towards the p-type region, in between there is a depletion region. The electron will penetrate through the depletion region. Okay, due to the charge deficiency in the depletion region, it contains the neutral atom. This neutral atom will broken up, and when it is interact with the photons from the sunlight, these neutral atoms, this is the one neutral atom, this is the one neutral atom, this is one other neutral atom. These neutral atoms broken up when it is interacted with the photons from the sunlight that strikes the depletion region. Okay, this knocks the electron from the neutral atom, the leaving behind the hole and producing the free charge carriers. Then electrons move towards the n region, and holes move towards the p-type region. Due to the electric field developed in the depletion layer on connecting the electronic circuit, electron flow through the generating electricity to electrical current electrical circuits like bulb. So I will try to explain in detail. Okay, so the solar cell. So the summary, what I'm trying to say is summary. The solar, this is a solar cell. Okay, each solar cell can produce 0.5 volts of electricity. Okay, if you want the combined the combination of all solar cells is called as a solar panel. Okay, understood? So how this photovoltaic effect is, when a solar cell, when sunlight the falls on the solar cell, electricity will generate. So generation of this electricity by this effect is called a photovoltaic effect. So what's the physics behind the generation of electricity in the solar cell? So solar cell is made up of n-type region, n-type semiconductor, and p-type semiconductor. Okay, so when we join these two semiconductors, n-type semiconductor and p-type semiconductor, so what will happen, there is a flow of electrons from the n-type region to the p-type region. So then there will be formation of depletion layer. Okay, so you have n-type region, you have p-type region, you have high concentration of electrons in the n-type region, you have the high concentration of holes in p-type region. Okay, so there will be the electrons in the region of near the region of p region. There will be holes at the near the region of n region. So when sunlight when so there will be neutral atoms in the depletion region. When the sunlight falls on the top layer of n-type semiconductor, the electron will try to flow from the n-type to the p-type through the depletion region. So electrons will penetrate through the depletion region. Okay, understood. So when the electrons are falls on the deplete means then these neutral atoms, there is the neutral these are the neutral atoms will broken up when the sunlight will explode when photon interact with the neutral atoms. Okay, this neutral atom broken when it is interact with the photons from the sunlight that strikes the depletion layer. This so now this neutral so when the sunlight falls on the neutral atom. Okay, so when it is falls on the neutral atom, this neutral atom will be broken up. Okay, so this is the hole, this is the electron. Okay, this uh, this knocks the electron from the neutral atom leaving behind the hole and producing the free charge carriers. Then these free charge carriers like electrons move towards the n-type layer. So what does it mean is so the electrons are accumulated at the p-type region, right? P holes are accumulated at the near the n-type region. When sun interacted with when the neutral atom is interacted with photons from the sunlight, these neutral atoms will broken up. Then what will happen means electron will flow from the p move towards the n-type region. This the p holes are moved towards the p-type region, p-type layer due to the electric field developed. So there will be electric field developed in the depletion region and connecting the electric circuit. Then the electrons flow through generating electricity to electrical circuit like bulb. Okay, thank you. Thank you. So next I will continue the pin diode, which is same like so when comes to the pin diode, so when comes to the pin diode, so pin diode looks like this. So you have the uh, p-type material, we have n-type material. In between there is a intrinsic semiconductor. Intrinsic semiconductor means there is no dopants in that semiconductor. So n-type semiconductor means there is a um, uh, pentavalent impurities will dope into the n-type semiconductor. Trivalent impurities are doped in the p-type semiconductor. So in between the p and p here p indicates the p-type semiconductor, I is the indicates the intrinsic semiconductor, n is the n-type semiconductor. So it is a, and pin diode is the sandwich of intrinsic semiconductor is a sandwich of n-type and p-type semiconductors. So pin diode is formed by sandwiching the intrinsic layer high resistivity about 0.1 ohm meter between the p-type and n-type semiconductor to create an electric field between them. So due to this large magnitude of electric field, the electron hole pair generation will augmented augment up to a large extent, and this in turn you can process even a weak electric signal. So I will explain in detail what is the pin diode in detail in the coming few minutes. So basically the pin diodes are work like a pin diode is work like a photodetector when it is connected in a reverse bias condition. Okay, so when pin diode is unbiased, the charge carrier will flow from n-type region to the intrinsic region due to the concentration gradient. So what happens is here plus sign indicates the heavily doped. Here plus sign indicates the heavily doped of impurities. Okay. Here cathode indicates the negative terminal, and anode indicates the positive terminal. When pin diode is unbiased, the charge carriers will flow from the n-type region to the intrinsic region due to the concentration gradient. Thus, the width of the depletion layer at Ni will be more on n side or less on I side. The region behind this n-type material is heavily doped, while intrinsic layer is not doped, or doping level is very extremely low. When charge carriers, electron majority carriers in the n-type flow from n-type to the intrinsic layer, the depletion region will be created. But width of the both n side and n sides of Ni junction will be different. Okay. So let me explain how it is work. Let us take it is the n-type region. This is the intrinsic semiconductor. This is the p-type semiconductor. So when we connected in the reverse bias condition, so there is a high concentration in n-type region. Okay, so this negative charge so negative terminal of this battery is connected to the n-type region. So there will be repulsion between the electron and electron in the n-type region. So electrons which are coming from this negative terminal having the repulsion with electrons in the n-type region. So the electron so there will be the repulsion, so that the electron will try to flow into the intrinsic semiconductor. This is the way the electron will flow. Then so there will be a formation of electric current. Okay. So if we consider the applications, advantages of photo detection, high voltage rectifier, the radio frequency switch, photodiode, attenuator, and RF protection circuit. Okay. So thank you.